For this video, we're going to do some basic dimensional analysis problems using one compound. When we get to multiple compounds, you're going to see those videos are going to be labeled stoichiometry, and that's what I kind of think of when I think of stoichiometry, is we're going to be doing essentially the same exact thing, same exact math, but with multiple compounds in a chemical equation. But these are more basic. This is what we're currently working on. What I do is I always start with the given value and I look to see what it's asking me to find. So we're starting off for this first problem with 3.4 moles of sodium sulfite, and it's asking us to find the mass. So I'm going to go ahead and get started with 3.4 moles of this substance. And I do need to go to mass eventually. I do need to get there. And because I need to get to mass, I need to figure out what is the chemical formula for sodium sulfite. And if you're not sure yet why that's important, you will be seeing that before the end of this problem. So sodium sulfite, I'm going to write that up in the top of this fraction up here, but I'm going to show my work off to the side. You have sodium, which if you look at your periodic table has a charge of +1, and sulfite is SO3. It has a charge of -2, and that's on the back of the periodic table. So for our school and for our district, we're allowed to use a polyatomic ion chart to help us remember the most important and most common polyatomic ions and charges. And sulfite is one of them that's on the back. So what we're going to do is I tell my students it's a crisscross. So we crisscross our charges. I know another teacher that calls it the disco, and I think that's fantastic. So this means for every for every 1 sodium, we have, or a 1 plus charge, we have a 2 minus charge here. So in order to cancel this sulfite out, we're going to need 2 sodiums. So 2 sodiums for every 1 sulfite. So we're going to write that like this, Na2. Notice how it looks like we're just kind of bringing this number 2 down, which is exactly what we're doing. And sulfite, which is SO3, and it's pretty much the same idea as bringing this invisible 1 down, and it stays invisible. So this right here is sodium sulfite, and I'm going to write that in my work because that will help me. If you are very organized and you keep everything written in your work, you are actually way less likely to make mistakes. And I learned that firsthand when I taught algebra, is the students who made the most mistakes weren't showing their work and they weren't organized. And they thought they were getting everything wrong. They didn't understand it when in fact they did. They were just making small mistakes because they weren't organized. So it's always important to stay organized. So for dimensional analysis, we go moles on top. We're going to put moles on the bottom. We're treating moles like a unit of measurement. And it's asking us to find the mass. So I know that for every 1 mole of a substance, I can get the mass of that substance from the periodic table, because everything on the periodic table equals 1 mole. I went ahead and I paused the video and I calculated my molar mass, and I got my molar mass is 126 grams of sodium sulfite per mole. I got this number by adding up sodium twice, plus 1 sulfur, plus 3 oxygens, and I rounded everything to the nearest whole number. So for sodium I used 23, for sulfur I used 32, and for oxygen I used 16, and I just made sure to account for those subscripts as well. So right now I'm kind of at a stopping point. My mass is at the top of my last fraction, and that's exactly where it needs to be, so I can stop right there. And my mole on top and mole on the bottom cancel out. If it doesn't do that perfectly every time, then you set up the problem wrong. So that's the thing I kind of like about dimensional analysis, is it's a set way to go through step by step every single problem, no matter what, and it works every time. So what I've got to do next is I have to go through and multiply these two things to get my final answer. And I'm getting 428.4 grams of the substance. Now, if you are looking at sig figs, we're looking at our original question. There's 2 sig figs in our original question. So I need to have 2 sig figs in my final answer. Well, this is currently 4, and that's not going to work. There are a few different ways you can put 2 sig figs in the final answer. A lot of people find it easier to convert it to scientific notation in order to do that, but that's not necessary. What I'm going to do is I'm going to round this up, because if I round it to 430, that 4 and the 3 would be my sig figs, and this 8 would make this 2 round up. So we got to apply standard rules. I just had a teacher tell me if you round up your grade, then you should really round up science, which I thought that was a fantastic quote. So we're going to round this number up just so that we have the correct number of sig figs. So the final answer is 430, no decimal, because if it was a decimal, it would be 3 sig figs. So we got to keep it with no decimal. And it's going to be grams of sodium sulfite. So the thing with these questions is a lot of my students have gotten confused in the past because they feel like they have to use Avogadro's number. Where's that 6.02 times 10 to the 23rd? Where is it? It should be here, but it's not. Because we're going straight from moles to grams, we don't need to use Avogadro's number. So I'm going to take a moment and I want to share with you GMA, which is something that someone else taught me. It's GM. So we say GMA knows best. All grandmas know everything. They're fantastic. I love grandmas. So we can go from grams to moles. If we wanted to go from grams to atoms, we can't just jump around. We have to go all the way through. So it's almost like a train station. A train can't jump from A to G. It has to travel through M. So this is grams, moles, atoms. You have to go back and forth in between. This problem, we're starting at moles, and it's asking us to find the mass, the grams. So I'm just going back and forth here. It would make 0 sense for me to take a step back if I need to go forward. So we're only going moles to grams here. Now for this next problem, before I get started, I want you to pause the video and I want you to try it on your own. Do your very best, follow the similar steps, follow the similar procedure, and then unpause the video and go through it and correct any mistakes you made. And best case scenario, it was perfect and you didn't need to watch the second half of the video, and I think that's great. Also skip ahead to the end. You can skip ahead to the end, check your answer. If it doesn't match mine, then rewind it and take a peek and see where you possibly made your mistake. So continuing forward, this question is asking us how many molecules, so we're going to have to go to atoms, makes up 0.72 grams. I'm assuming this word should say of. I must have had a little typo there. I apologize for that. Magnesium phosphide. So we are going molecules to grams. So we do have to take that mole step in between. We have to go all the way through. So I'm going to go ahead and get started by writing down my given number, which is 0.72 or 0.72 grams. And since we are using grams, just like in the previous problem, when we use grams, we have to go to the periodic table. We need to write down our chemical formula. So before I do anything else, I'm going to write down the chemical formula. Magnesium has a charge of 2+. Phosphide, it ends in IDE, so that's just phosphorus. It's not PO3 or PO4. And if you look at your periodic table, that has a charge of 3-. And like I tell my kiddos, crisscross applesauce. My friend calls it the disco. It's a disco dance. So magnesium now gets the subscript of 3, and potassium gets the subscript of 2. Reason being is I need 3 of these to get a charge of +6 total, and 2 of these to get a charge of -6 total, and +6 and -6 cancel each other out. So by crisscrossing those numbers, we're getting the same overall charge. They're canceling each other out. We have a nice neutral compound. So this is going to be Mg3P2. Forgive me, this pen is kind of difficult to write with. I'm surprised I can even read what I have so far here. So if grams is on top of this fraction, I always put grams in the bottom because it's going to have to cancel out perfectly. If it doesn't, then I'm not setting it up right. So it's Mg3P2, and I don't have any more grams, but I do know if I get it from the periodic table, it will equal 1 mole of that substance. So I don't think I'll need to pause the video to do these calculations. They're pretty straightforward. In my calculator, I'm going to put 3 times 24, because 24 is the mass of your magnesium, and there's 3 of them. And I'm going to add that to 2 times 31, and 31 is the molar mass of phosphorus. Now, I'm using a scientific calculator, and I know you cannot see it, but I am plugging in parentheses. I'm making sure I use my order of operations. If you don't know how to use your calculator properly, it's not really going to help you much at all. So make sure you are very, very deliberate with how you push every button and how you set it up. So for the molar mass of magnesium phosphide, I got 134, and like I told you, I used whole numbers, so I don't have to worry about those decimals. I'm not really concerned about that at the moment. And I'm going to continue forward because I need molecules in my final answer. I'm done with grams because they cancel out. So moles is on top. I have to put moles on the bottom. And I know for 1 mole, I have Avogadro's number of molecules times 10 to the 23rd. Common mistake I see all the time. I have students say, but I put molecules. Well, if I were to put MOL here to abbreviate molecules, what else does it look like? Does it look like anything else to you? So yeah, it gets really confusing. So instead of molecules, sometimes what I'll do is just to abbreviate to make my life easier, I'll write particles, but I'll abbreviate it part. So molecules, particles, atoms, it's really all interchangeable. It doesn't matter. We're still using Avogadro's number. So this is my favorite part. I have grams on top, grams on the bottom, canceling it out. Moles on top, moles on the bottom, canceling it out. I have particles as my final unit, which is exactly what I'm looking for. Molecules and particles are the same thing. And now I'm going to pause the video for me, and I'm going to plug this into my calculator. All right, this is the value I got in my calculator. And what I did is I just multiplied my regular numbers. I brought my 10 to the 23rd down, and then I multiplied 0.72 times 6.022. Then I divided that number by 134, and this is what I got. This is not technically correct scientific notation. This is not technically the final answer. I'm not going to go over how I'm going to switch this up in great detail and change it to scientific notation, but that is in other videos about a basic dimensional analysis using a metric chart or a metric table. So I'm going to do a very brief explanation. First and foremost, I have to have a 1-digit number, so I'm going to change it to 3.2. Got to change it to 3.2 by moving this decimal place over. I'm making the number bigger going from here to here. So if I'm making this bigger by 2, I'm going to have to make this smaller by 2. It's a give and take. So it's going to be times 10 to the 21st power particles. And it's going to be particles of magnesium phosphide. More videos are coming, and if you have any questions at all, make sure you watch other videos, pay attention to other videos, and then you can ask me in class. Thanks.